Now, I don't know if you remember when I said this, but a little while ago I was talking about how the area underneath the curve is like the accumulation of something, assuming it was a rate. Like I made an example of, say, driving a bicycle 15 miles per hour. And like if I'm imagining every hour, the area underneath the curve tells me, well, how many total miles have I driven? It's sort of like how a derivative is a rate. It tells me how, if I'm, my function gives me position, tells me how fast I'm going. Well, an antiderivative of a rate will take me back to the original amount, and it'll give you kind of the accumulation of what's occurred over that period of time, because it's associated to the area under the curve, which is kind of why this makes sense. But let's look at example number 6. It says, let's say we have a profit function, P of X is equal to 50 divided by X in dollars per hour for selling sunglasses at the beach for a total of X hours. So imagine that this function gives you your profitability rate for how much how much profit you're gonna make based on how long you sold. And it says a minimum of 1 hour and a maximum of 10 hours. And if you wanted to look at what is the graph of this function P, what does it look like? Since it's 50 divided by X, over time it will get smaller, just like a reciprocal function, something kind of like this. And what it's saying is from 1 to 10 are the valid components of the domain. And if it were 1, it would start at $50 per hour, because 50 divided by 1 is obviously 50. And then if we spent 10 hours selling sunglasses at the beach, 50 divided by 10 would be 5. And our rate would get smaller and smaller. Basically, the longer we're going to sell, the smaller our rate will be. And this sort of graph is fairly, I wouldn't say realistic, but it's relatively realistic, because it's like if you only spend a short amount of time selling something, there's usually more people that will buy. But the longer and longer you spend, you'll tend to have less and less sales over time as you run out of new customers. Again, this is not always going to be the case, but again, let's just assume what this will be. But essentially, the area under the curve describes how much actual profit they would have obtained, because this is not actually a profit function; it's a profitability in dollars per hour, which is kind of like the longer, and I would call it a profit rate function. You could even call it P prime, where it's in a time frame. But if we actually integrate this function, so if we take the antiderivative of 50 divided by X, and actually, so this is part B. Sorry, I'm kind of getting ahead of myself, but we wanted to graph it and kind of talk about it, which I did up there. But it says, say you wanted to calculate the total profit for selling from 1 hour to 4 hours, and what if you stayed all 10 hours? We could set this up as the antiderivative or the integral from 1 to 4 of our function 50 divided by X with respect to X. And if we stayed all 10 hours, we'd just adjust that from 1 to 10. But basically, I could solve the antiderivative in order to solve the definite integral. And the antiderivative of 1 over X, again, we could pass the 50 through. You can apply the properties that we talked about in a previous video, like so. And then, as we know, the antiderivative of 1 over X is the natural log. So I'd have 50 times the natural log. Also, I wanted to mention, if you factor out a number through your antiderivative before solving it, what will happen is you can, take the antiderivative like this. And, the antiderivative of 1 over X is the natural log of X. But one thing you want to be very careful about is that this 50 is multiplied to the entire antiderivative, which means that as we plug in, remember, we need to plug in 4 and then plug in 1 and take those away. I need to make sure 50 is distributed to those two numbers. So in this case, I'd have 50 distributed to the natural log of 4 minus the natural log of 1. I just need to make sure that those are being subtracted and the 50 is distributed to both. That's something that's very easy to forget. And, the natural log of 1 is 0, and what I would end up with is just 50 times the natural log of 4 exactly. Or again, of course, I could approximate that to see, well, what is that as a number that more your average person would understand, but that gives us about 69.31. And this is in dollars. This would be a profit. Basically, our original function was a rate of how much was sold per hour. And this gives us the total amount of profit for spending 1 to 4 hours. And again, kind of would be correspondent to the area under the curve. It's like, well, after 1 hour was spent, we would have that much profit from selling, because the rate started at $50 an hour and it decayed very, very rapidly. And from 1 to 2 hours, that would be our profit in that window. But, spending a total of 4 hours, what we can see as our profit is about $70. And I could ask myself, well, how long is it worth it to stay? Like, what if I stayed for 10 hours? Again, we could do this. Let's go ahead and just calculate with a calculator here, the antiderivative, or the integral of 50 divided by x from 1 to 10. And we'd see that if we stayed for the full 10 hours, our profit would be more like $115, which is technically a worse rate because the rate gets worse and worse over time, but it's still more. So you can kind of weigh the options, say, well, is another 6 hours worth another, little $48 in profit and whatever.